Okie dokie, we're nearing the end. 3 more systems that you're going to hear from me about. All right, so last but not least, these are the ones I'm going to cover the next couple lessons. So you're looking at sections 9 and 10, the respiratory, okay, so where's that? The respiratory right here, yeah. And the excretory, yeah, right here. And the reproductive systems, everyone's favorite, right? Okay, so I'll take a break between each one of these, but those are the last 3 systems we'll cover, and then we will be done with animal organization. So I'll be sad, but it's okay. So another song to start us off, because you guys know that I love songs and they're pretty wacky and they're pretty funny. This one we're not going to listen to the entire thing because it's pretty long, and you guys will see why, but it's kind of funny. So watch this.
Oh my god. Miss Lee, look at those lungs. It is so big. It looks like one of those athletes' lungs. But you know, who can ever run as fast as those athletes? They only use it because they need a lot of oxygen carry. I mean, their lungs is just so big. I can't believe it's just so spacious like out there. I mean, those. Look! It has so much sacs. I like big lungs and I cannot lie. The other organs can't deny. When some lungs walk in with a whole lot of space and air goes in your face, you get oxygen. And it goes to your nose cause you know that air stops. Your nostrils open flaring. Your nose has starts repairing. Oh baby, it goes down the pharynx and then the larynx. Your voice box shadow on me. Without voice you got so sounds a whole say. Ooh, rumple smooth skin. It goes on jiggle within. Well, use cause it has in the alveoli. Respiratory system dancing and begin asking, am I wet? Sweat? I be feeling like a turbo vet. Or to diffuse in until to leave the scene. The average man does not know that. He's gonna say whack. So fellas, yeah, do you need the oxygen? Heck yeah, so inhale through those healthy lungs. Your lungs aren't whack. Switch to the bronchioles. What the hell? Bronchioles, bronchitis, and bronchioles. Your lungs are red, bronchitis, and bronchioles.
Okay, you guys get the picture here. So anyways, kind of funny. Gotta laugh a little bit. But we are going to go through a lot of that stuff so that if you decide you want to listen to it again, then maybe you'll understand what it's talking about. Okay, so time to breathe. Take a deep breath because we're going to talk about the respiratory system. So the functions of the respiratory system are basically it allows the body to take in oxygen, to be transported all over the body and dispose of carbon dioxide out. That's a waste product. So basically you're taking in oxygen and then as it does that, it's taking all that oxygen to all the different parts of your body. Then when you breathe out, you're expelling waste, which is carbon dioxide. So it's very important. We're going to get into all of these different pictures here, this being one of the most important parts, the alveoli or the sacs. That was mentioned in the lovely song, but we'll get into that in just a bit. But really, the respiratory system has a lot to do with just the lungs, although there are some other organs of well, we'll talk about that more in the excretion portion when we get to the excretory system. But yes, so the lungs are a huge part of the respiratory system, clearly. So here's some more components. The lungs, the trachea. Okay, remember the trachea is basically this big, thick pipe. And the cool thing about this pipe is it's not flimsy like the esophagus and the digestive system. It has these rings of cartilage that line it, and you can kind of see it in this picture. But basically, if you think of a vacuum hose that have those rings around it, it's to keep that nice and wide open. You don't ever want it collapsing because you have constant air moving in and out through there. Your bronchioles, which basically are all these tree-like things that kind of branch off in your lungs. They're little pathways, so to speak, that basically make their way down to the alveoli right here. And then the diaphragm is also part of the respiratory system. It's this muscle here. The diaphragm is really important because we don't realize how much of a part that plays in inhalation and exhalation. That basically the diaphragm here is this muscle right under the lungs here. And when your diaphragm contracts, it basically allows the lungs to widen and bring air in. And then when it expands or relaxes, or kind of, I don't want to say relaxes, but it basically lengthens, then it pushes those lungs and forces air out. So if you didn't have this diaphragm, which is kind of this dome-shaped muscle that goes right underneath here in the rib cage, you would have a really hard time breathing in and out because it's helped by that muscle, okay? So I will get into the alveoli a little bit more, but I talked about each of these a little bit. The bronchioles, again, just kind of that network of pathways that lead to the alveoli. So oxygen exchange is one of the most important things about the respiratory system, because basically you need somehow to get oxygen into your blood, and you want to take the carbon dioxide out. So we call that the oxygen exchange. And it happens in the alveoli, okay? So again, at the end of these bronchioles, you have these little sac-like things. They look to me like grapes, but they're little teeny microscopic sacs where blood vessels are covering the entire thing, and basically via diffusion. Remember, diffusion is anything that moves from a higher concentration to a lower concentration. That's how things move through something that's kind of permeable. Well, think about if you breathe in oxygen, the oxygen is really condensed in this area and not so much inside. So oxygen is going to diffuse into those alveoli. So now it's in the lung structure, where carbon dioxide is going to diffuse out, and we're going to breathe that out. But then you have, obviously, through the alveoli, all that oxygen will be taken back up towards the heart, where it's going to be pumped. It's going to be part of that blood, basically. I think I actually just explained that the wrong direction. Okay, so the oxygen will be in the alveoli. I don't know why I was thinking to be outside. So I'm not sure if I just explained that wrong. Oxygen will be in the alveoli and diffuse out into the bloodstream. Okay, so the blood, then that's taken back to the heart, where then it can be pumped throughout the body. So I think I just explained that the wrong direction. So obviously, carbon dioxide will come from that blood that's deoxygenated. It'll diffuse back into the alveoli to be exhaled out, but oxygen will diffuse out to the bloodstream. Sorry if I just confused you people there. So diffusion occurs through the thin walls of the alveoli sacs. Very important. If we didn't have that mechanism, we wouldn't be able to transport oxygen throughout our bodies. Obviously, that has to do with the blood in the heart as well, but we need a way to get it into the bloodstream. So that's what happens in the lungs. Okay, so no matter what creature you are, you have the same basic function of the respiratory system, where you have that gas exchange. So you'll notice that in every type of animal organism that you have that exchanging of oxygen and carbon dioxide. Okay, and here's just some pictures showing you that the CO2 is coming from these blood cells back into the alveoli, where the oxygen is going to go the opposite way. It's going to come from the alveoli into the blood and hook onto basically that hemoglobin that's on the red blood cells and binds to it, and then it can be transported around. So here's just another in-depth little look at it. So if you guys want to take some time, pause it right now, take a look at this a little bit more in depth, because this shows kind of the basic pathway and what exactly is happening in a little bit more detail. Okay, so kind of on to some disorders too. Smokers. I know a lot of you guys might be smokers, maybe not. Not good, okay? Obviously, this is the difference between a smoker's lung and a non-smoker's lung. It's basically killing off those alveoli, okay? So it basically deadens that, so then you don't have the ability to exchange oxygen like you normally would. So lots of smokers tend to cough and hack out stuff because they're not able to exchange as efficiently as someone who doesn't smoke. So if you end up smoking a lot, it can lead to lung cancer and emphysema. Emphysema, again, is showing that basically these alveoli are just kind of filled with the chemicals and the tar that basically builds up in your lungs because of smoking, okay? So obviously, if your alveoli are looking like that, you're not going to be able to exchange oxygen as if they were like the healthy alveoli, okay? So it can damage also the cilia that lines the trachea. The trachea has these tiny little hairs that line, the entire pathway. And what happens is that cilia can easily move up mucus that doesn't need to be, down obviously in your lungs. It can move it up on its own. So a lot of times you don't even know that maybe you have mucus buildup unless you're sick and you have an overproduction of mucus. But there's constant movement of mucus out of your trachea. Well, when you smoke, you kill those off. You deaden those cilia. That's another reason why you're coughing and hacking, because that buildup is so much more than what it is normally, because normally your body's taking care of that. All right, some other common disorders, asthma. Some of you guys might have asthma, whether it's activity-induced if you're doing athletics. Sometimes that is something that just stimulates the asthma attack. But asthma attack is basically where all these little bronchioles, they can start to narrow, okay? So during an asthma attack, here's what it would look like. basically you start to have these walls that kind of thicken and close in, almost like a blood vessel that constricts, okay? And you have so much less of a pathway for air, so you're really trying to gasp for breath. Now, thank goodness I don't have that, and I never have, and that would really scare me, because think about how hard it would be if you couldn't breathe and you were gasping for air, yet nothing's hindering you, it's inside. So obviously there's inhalers that basically act as kind of this relaxant to the muscles that are in these air passages and just kind of open them up again. Okay, sometimes there's steroids that people have to take in order to kind of open up those airways. So kind of a bummer thing, but some people do suffer from that. Bronchitis is inflammation of the bronchi or bronchioles. Okay, so all of these little branches here, if you get some kind of a bacteria, you can have kind of a infection, and it'll cause inflammation of all these little tubes. Well, again, then you get all that mucus that starts to back up, because look at, you have these narrowing of these walls, and things aren't able to kind of flow through and flow out of your lungs like they're normally supposed to. So if it's inflamed, you're typically coughing up a ton, kind of this horrendous cough. So again, here's kind of a narrowed airway. There's some inflamed areas of the bronchial tube. The cilia can be damaged. And it says right here, with chronic bronchitis, the lining may stay inflamed and the cilia may not function. So therefore you have all that phlegm and mucus that's kind of just building up in your lungs, and you need to get it out, okay? Bronchitis can lead to pneumonia sometimes if you have that infection that stays within there and you're not able to kind of get that stuff out. It can lead to worse things. Okay, cystic fibrosis is another common disorder. This is actually a genetic disorder. Where basically it's a hereditary disease, and if you read down here, it says characterized by lung congestion and infection and malabsorption of nutrients by the pancreas, which is very interesting that it involves digestion as well. So what happens is someone with cystic fibrosis has this build-up of congestion and mucus, okay? And what sometimes you have to do if you're a parent of a child with cystic fibrosis is you take your hands and you cup them, and it's called percussion, and you have to beat on their back in order to break up that mucus within their lungs and get it out, because they don't have the functions, the normal functions that would bring that stuff out normally. Okay, so it's really kind of a bummer. And then also it's interesting, but for some reason cystic fibrosis affects the way that the body can absorb enzymes. So basically, a lot of nutrients, people with cystic fibrosis don't get the nutrients they need, and they have to take extra enzymes in order to break down their food. Cystic fibrosis is a very devastating disease. Most kids do not live past, I would say 6, 7, 8. It depends on each, case, but it is a genetic disorder. So you can be a carrier of the disorder, and you don't have full-blown cystic fibrosis, and you're fine. But say if a father is a carrier and a mother is a carrier, okay, so even though they don't have cystic fibrosis, they're carriers of the gene. So basically, when you do a Punnett square, if you guys remember that from genetics, if you do a Punnett square, you have a 25% chance of a child with cystic fibrosis. So a lot of these people tend to get tests done if they are pregnant, or choose not to have any more kids because they have that 25% chance of having a child with cystic fibrosis, and it's a bummer because there's nothing that people can do to cure cystic fibrosis. So it's a big deal to be a carrier of cystic fibrosis, and especially marry another carrier when it comes time for having kids. Okay, so more on cystic fibrosis. There's a lot that are affected by that. The sinuses, you have a lot of sinus infections. The lungs I talked about. The skin is typically kind of sweat glands produce very salty sweat, which is interesting. The liver, there's lots of bile duct clogs, basically. They can be blocked a lot. The pancreas, the ducts of the pancreas can be blocked, and therefore, again, not able to secrete the enzymes needed to break down food. The intestines can't fully absorb the nutrients, which is a big deal. If you can't absorb the nutrients, you're not getting what you need in your body. There's complications with the reproductive organs. And then here's what the airways look like. So in the bronchies or the bronchioles, you have a normal airway that's obviously clean. But here with cystic fibrosis, it's thickened, and then basically this mucus kind of builds up and blocks the airways. So again, makes it tough to breathe. You have to get rid of this manually by doing that percussion. Okay, so we're done with the respiratory system, but let's end on one more song, right? This one's kind of funny, really weird, but see if you can catch some of the terms, because there's some long terms in it, but it does all make sense if you kind of know a little bit about what he's saying. Here you go.
So you breathe in, breathe out, oxygen coming in all the way down into. Here comes the body food into your lungs, into your revia. Tastes kind of like ravioli. Down an artery, 1 cell thick. The oxygen passes down into capillaries, then goes into the bloodstream. From the blood cells into the body cells, then it comes out as carbon dioxide, also known as CO2. Then back to the blood, back to the lungs, you breathe out. Breathe out. And it came through your body, yes, 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 it came through your body.
Scary, right? Okay, but kind of funny. Like they were going to start moshing or something all of a sudden at the end. Okay, so there is the respiratory system, and we'll be back with the excretory system.